welcome once again. And today, as a speaker, we have Dr. Jan Argasiński, who is at that moment, since 1st November, a new team leader of the team, which original name is Computer Vision, which topic is more or less related with computational neuroscience. And Janek is originally was affiliated with for a long time with the Faculty of Physics, Astronomy and Applied Computer Science of the Jagiellonian University. And he joined Sano in 2022. He was postdoctoral, senior postdoctoral researcher at Sano. And he at the moment, as I told, he is leading the computer vision computational neuroscience team at Sano. And in this presentation, Janek would like to discuss new research plans for computer vision team. And together with Janek, we have also the whole team. So if there will be something which will require participation of team members during the seminar, it will be present. As usually, if you have an urgent question, you can ask with question and answer or chat. I will transfer it to Janek. And as usual, there will be a question and answer discussion time at the end of Janek presentation. So, Janku, the screen is yours.
Thank you, Marian. Good afternoon, everyone. I will share my screen now. Okay, so this is the presentation and share screen, desktop 2, share, and the presentation. You should see the presentation right now. Can you see it?
Yes, it is. So I hope that it will be possible also to change slides.
Yeah, so I will try to change slide now. Okay.
Yes, it works.
Okay, so as the slide states, this is the greeting and an invitation for you, all people gathered on this Sano seminar, to work with us. In this presentation, I will try to show the wonderful people I work with here on the 3rd floor of Sano, and I will say a few words about research that is currently being conducted in this lab. And also I want to share the story about like soft transition of this group from computer vision data science, which is original name of the lab of the group, towards computational neuroscience. And I will try to ask questions. What does it actually mean, and what will be the results that will be observable in our research, in our actual research. I don't have a lot of news if you about the group, because if you witnessed Sano and particular groups activities, you are aware of what computer vision data science was all about. And I am leading this team since like 2 months. So not a lot of research was done during that time, but we have some solid groundwork, some fundaments laid. So I will try to tell you about the vision, about what I'm thinking about the situation we are in, the research that we are doing, and about like future that will come. And the first thing, of course, the most important thing in every lab is the team. So I would like to introduce or maybe reintroduce to some of you members of the computer vision computational neuroscience team. And I will tell a few words about their research. You will see later diagram in which you will be able to inspect how it looks like from the bird's view. So first, we have one postdoc in the group, Jamal Koba, and he has PhD in computational neuroscience, which is very appropriate at the moment, I would say. In his thesis, he examined structural brain plasticity in the case of early and acquired blindness. And now he works on brain connectivity difference due to ischemia. So the stroke research is something that he is very interested in, and we have some projects related to that. Even we even try to commercialize some of these projects, but this is a different story. Then we have PhD students, and the first PhD student is Monika Pytlarz, and she has a bachelor's in electroradiology and master's in bioinformatics, and she works on the application of generative adversarial networks to generate data that will be actually useful in diagnosis and clinical application. This is very novel, very interesting and cutting-edge research that raises a lot of questions from my perspective, but I will try to involve you in the discussion about on this topic a little bit later in my presentation, because artificial intelligence, especially generative artificial intelligence in the context of medical research, is something very hot and interesting right now, but also, like, I suppose, quite risky. Okay. Rosemary Blanco is a biotechnologist, and she has a lot of experience in processing and EEG data, so complex electrophysiological signal processing. And she did her research around dementia-related impairments, and right now she is also interested in stroke-related research using EEG and other modalities. Next PhD student is Joan Falco-Roget, and he studied physics and systems biology in Spain, which makes him, I guess, biophysicist. Can I tell it like that, or is it, if you study physics and biology, it makes you biophysicist? Okay, so his thesis was about computational neuroscience, and in the context of learning role of dopamine, and now he works on neuroplasticity after tumor and stroke, and on surgical planning. And last but not least, a PhD student is Mahmoud Nasr, who has degree in electronics and communication engineering, and he's now pursuing PhD in biomedical engineering, and he's interested mainly in processing imaginary and medical image processing. Yeah, he started working at Sano in 2022 at the clinical data science team, and now he moved to our team and continues his research that will be pivoted towards more neuroscientific objectives in the near future. So this is most of the team. We also have a scientific programmer, Szymon Mazurek, who also happens to be PhD student at the AGH, where he's working on neuromorphic computing related projects. And also we have Ewa Żukowska, Weronika Pyrka, Kacper and Kacper Jurek, who are volunteers. Ewa is master students, others are interns, and they work with me on topics related to neuromorphic computing and spiking data processing. And at the end, there is me. Marian introduced me, so I think I don't have to dig very deeply in this description. But yeah, my main interests right now are in neuromorphic computing and computational neuroscience. But I have background in affective computing. I did some projects on affective computing. And I have also, I did some projects with virtual and augmented reality in the past, like commercial one and R&D, and some R&D projects. Okay, so this is the team, and we started this year as computer vision data science. And of course, as you well know, computer vision is a field of artificial intelligence and computer science that is focused on enabling machines to interpret and understand visual data from the world. Whatever understanding means, we can discuss this again a bit later. And we are dealing with data such as images and video. And data science is also interdisciplinary field that focuses on extracting knowledge and insights from data using combination of techniques from different domains, like statistics, computer science, but also like domain expertise, which is very important in the context of medical practice. Eliciting knowledge from specialists is something that is very hard and very important in medical-oriented research. Okay, so, but this story is about transitioning towards the area of computational neuroscience. And computational neuroscience is, like, at least as I think of it, is like level higher in the abstraction. So again, it is interdisciplinary, it's scientific field, but it's about using mathematical models, algorithms, simulations to understand the functioning of nervous system and particularly the brain, of course. So it connects computer vision, data science, computer science, artificial intelligence, and this is like more general field of knowledge, but also like more like coherent. It's like particular view, worldview that you can adapt, and particular like set of methodologies that you can adapt to study a very particular type of phenomena. If you think about it, like, there is nothing inherent in computer vision and data science that tells you that we are dealing with neuroscience. Yeah, with describing how neural circuits process information, how it all drives behavior. There's nothing inherent about in this. In computational neuroscience, we are interested in neural circuits, neural systems. So this is the pivot. Like we are stating that we are working in neuroscience to look into the like a bit of historical like origins or historical facts on this. I wanted to mention like one anecdotal example of how it can be framed. So in 2013, the NIH US Brain Initiative was launched, and advisory committee to the director of National Institutes of Health was charged to chart a roadmap for this initiative, and with consultation with neuroscience community. And they produced a report that you can see here, the brain research through advancing innovative neurotechnologies, Brain Initiative. And this report identified 7 priorities, mostly focused on technological developments. And the priority number 5 actually recognized the importance of theory and computational models in neuroscience. So you can see here this priority 5. Rigorous theory, modeling, and statistics are advancing our understanding of complex nonlinear brain functions where human intuition fails. New kinds of data are occurring at increasing rates, mandating new methods of data analysis and interpretation. To enable progress in theory and data analysis, we must foster collaborations between experimentalists and scientists from statistics, physics, mathematics, engineering, and computer science. So this is like manifesto of computational neuroscience in some way, because when it comes to neural systems, we are dealing with adaptive, complex, dynamic systems, and that which behavior cannot be reduced or predicted from activity of its component. Yeah, we are dealing with phenomena such as self-organization and rich repertoire of dynamical states. So this new massive amount of data incoming require new tools. And of course, this notion that brain systems are too complex to comprehend with experiments and intuition alone. So modeling is required. So we need to model experimental results to advance our understanding of how neural systems works in different spatial temporal scales, because we are dealing with objects from molecules to circuits and to function, behavior. So very different levels of scale. Yeah, like there are different scales. Okay, so this is the like I said, manifesto of some kind of for computational medicine, and we use different like epistemological approaches to account for data. This is first and foremost in beautiful, simple way that is generalizable for testable predictions. So we create descriptive models, normative theories, and also this biologically realistic models, like 3 approaches that are, according to this report, of course, at the core of this kind of research. So this is what we are moving towards. And of course, it has to fit the Sano agenda and all the research that we conduct here at the lab. So I prepared like very simple diagram that shows how we may think about our future focus in the lab. So we have these areas such as data analysis and image segmentation and classification, which is, again, computer vision, data science stuff. Then we have predictive modeling and biologically inspired artificial intelligence as maybe not new, but like refocused areas towards which I would like to push the research of the team. And we have different ideas, different projects around that. So this is just, these are just some of actual projects, of papers, of proposals that are being produced right now. Some of these works mentioned here are already published, so some are in progress. So you can see we have image conversion, we have MRI analysis, we have connectivity gradients analysis, stroke imaging analysis, glioma grading, brain networks analysis, classification and explanation of traumatic brain injury, epilepsy detection in EEG, and of course neuromorphic computing. So these are like actually ongoing projects, because we need to like wrap up some projects that are legacy projects from previous time frame, and we will hopefully move with this research toward like more computational neuroscientific objectives like modeling and so on. So my personal hobby horse is neuromorphic computing. I've had presentation on that once here at SanoSeminars, so some of you may remember that. I won't repeat myself too deep, but just wanted to refresh that it all fits in relation to these modern problems of processing of this John von Neumann architecture in hardware that requires transfer between memory and processing unit, and is also like not very energy efficient. And of course, we could try to draw inspiration from the best computational hardware that we know about, and we carry it with us all the time, our brains, which is very energy efficient, and this is the origin of neuromorphic computing. The idea is, for example, to use spiking neural nets, artificial spiking neural networks to process data in different kind, to use alternative ways of teaching networks, and it can, of course, have application in medicine. These are different areas of research in which you can find application for neuromorphic computing. It's in diagnosis, in biosignal analysis, in neural interfaces, and in tools such as sensors, for example. So this is also applicable in medicine. So our goal is to create models that we can use, that can be applied in medicine. But I spent some time recently thinking about this application in medicine, and what does it actually means for such fields of knowledge as computational medicine, or like very academical projects. And I wanted to share with you one controversy. Maybe you will agree with me, maybe I will aggravate you to discuss with me. Let's try. Because if we have application in medicine, I found recently very interesting book that actually made me think about this stuff. And the book title is Medical Nihilism, and the author is Jacob Stegenga, sorry for that. And this is like food for thought in terms of like philosophical approach to things that we take for granted, that we think we have covered. Of course, first we have to explain what is nihilism. In this case, nihilism is not like worldview, but it's rather like belief that there is no like ontological basis for the values in the world, which sounds pretty strange when it's in the context of like medical research. It may be not so strange in the context of, for example, ethics applied to medicine, but in the context of medical research, it sounds strange, and it is indeed. But there is very nice framing for that. And what Stegenga does, he proposed to build Bayesian argumentation around the practice of medicine. And this is something that may be, slightly triggering for people who actually practice medicine and are interested in this project. But let me explain a bit, and I will maybe we can discuss it in a second. So he uses, of course, this Bayesian notion, and of course the probability of the hypothesis given H given evidence E is equal to the prior probability of the hypothesis multiplied by the probability of evidence given the hypothesis divided by the prior probability of the evidence. Yeah, so this is like basic Bayesian framework you are aware and you know very well. And Stegenga proposes as follows. Premise one is that P of age is low, so prior probability of any particular medical intervention being effective is low. Then premise 2, likelihood of evidence given the hypothesis of effectiveness is low. So evidence observed is unlikely given the hypothesis that medical intervention is effective. And then we have premise 3, the prior probability of positive evidence irrespective of actual effectiveness is high. So we expect positive evidence no matter if the medical intervention is actually effective, yeah, because this is how our research context for the research is framed. And in conclusion, he says the probability that medical treatment is effective given evidence of its effectiveness is low, which is like super controversial for people who work in the medical area, or it's not. I will ask you in a second. And he gives even like in-depth argumentations behind that. So, for example, for this first premise, there is argument from past medical failure. For example, most medical intervention in the past failed to be effective. This is like the fact about the practicing medical research. Or the argument from paucity of magic bullets. So these super effective treatments happen, but they are very hard. They're very rare. Yeah. So, for example, with antibiotics, we have insulin and other like magic bullets for particular diseases, but there is like very few of those. And we have for premise 2, we have best evidence. We have fact that best evidence concerning many treatments suggests that they have very minimal positive effects. So these positive effects are observable. They are important, but they're like very minimal usually. And of course, there is problem with evidence is a mixed bag. Yes, some are positive, some are negative. It's very hard to find a way around that. And the third part, this expectation of the evidence being high, is because of medical evidence are malleable. Yeah, so you can like, interpret results in various ways to achieve results because you are expected to have results. And of course, because there are significant incentives for you to find positive effects. So you will find them because, for example, negative effects are rarely published. Yeah, and we are interested in publishing. So this is the construct. And of course, some may say, like from the first side, it may sound like, okay, this is anti-scientific. This is horrible. We shouldn't think about science in that way, like diminishing way. But if we think about it, this is actually very scientific way of thinking because it urges us to be very skeptical about everything that we witness, everything that we achieve. And of course, Genga calling it nihilism, it's like publicity trick because everyone is like, okay, so nihilism is so intensive, yeah, it's like so huge, so big statement, yes, that there are no values in like there's no basis for our beliefs in medical treatments. But he says, no, it's like, no, it's not that there are no bases, but there is like just need to be very cautious about it. And why I'm showing you this? It's because, of course, it's related to our field of interest, which is computational medicine, just medicine. So it's medical, and we could ask ourselves if our discipline is not touched by this kind of very particular nihilism. But also we can think of and propose maybe something that we can call AI nihilism. So what are bases, how we base our belief in works of artificial intelligence and AI systems. This is very important question when it comes to this line of research, and it's even becoming like more general question about artificial intelligence right now, or computational intelligence, because we are witnessing right now the what is happening with phenomena such as large language models. Like some time ago, we may believe that this is something like new wonderful tool, and we will have soon practitioner, like virtual artificial practitioners that will discuss with patients in empathetic manner, and they will be experts and so on. And what we see on the market of LLMs is mostly like horrible hallucinating avatars of corporate presence. So this is something that is actually happening, and I think we should think about it. We should start thinking about it. What does it mean when we, for example, treat models, when we work in this way, in this abstract way? And of course, it relates to something that is, again, becoming more and more important part of artificial intelligence research, so-called alignment problem. So how do we know, or how do we secure that our artificial systems will realize our human values? How we secure the alignment of their behavior with our goals? This is not at all obvious, and I think, of course, the one way of securing that from our perspective, for example, in medical research, is to embody it as fast as possible, to reconnect it as straightforward as possible with actual reality on which we build these models. So in our case, with doctors, patients, users, and clients. So this is like philosophical. Maybe it's too abstract, maybe it's too philosophical, but this is like problem I actually am thinking about when I think about what we should do in area of computational neuroscience, and how we should connect back to the reality from which our data is derived. So to end this dark nihilistic view, which of course is actually not that dark and not that nihilistic, it's just skeptical, which is a good thing in the case of science. I end with a joke. You may know this famous XKCD strip when we have fields of knowledge arranged by purity, when psychologists say to sociologists that sociology is just applied psychology, psychology is just applied biology, biology is just applied chemistry, and so on and so on. And at the end there we have the mathematicians that are far, far, far away behind everyone, like so pure. So I thought that maybe looking at this image, maybe we are on the right side, where we build artificial models and we do simulation based on the data, which is abstract, which is like disembodied from the actual objects it was derived from. And maybe like we are far on this right side, and maybe we should look more frequently and move more frequently to the left side, where there are like things and objects that we care about, that we have ethical obligation towards, which makes all these technologies more humane. And this is, if it sounds like abstract manifesto, it is that way because it is an abstract manifesto, but this is how I would like to frame our research. And with that, again, with this greeting and an invitation to cooperation, I would like to conclude my presentation. Thank you for your attention. And of course, I have all members of the lab gathered here. So if you have any questions about this particular lines of research, of topics that you can see here on slides, you can ask these questions. But of course, I expect in the future we will have presentations, maybe not on each and every of it, but like most of these topics. Thank you very much.
Thank you very much. Now we have time for questions, answers, and discussion.
Is this topic provocative for any of you? Like, do you find that this nihilism topic interesting at all, or is it just philosophical?
Well, I think that before we will have other people with questions, I would like to ask you how you see the goal of your team. Let's say at the end of this year. So, what is the most important for your team at the end of this year? What do you plan to achieve in the end of this year?
Okay, so this has two aspects, I would say. The first aspect is somewhat technical, but very personally important for members of the lab, because most of the lab are PhD students, and they really want to finish their PhDs. So there is research that is actually in progress right now, and it is about time to wrap up this projects and you know, get the degree. So this is like technical goal. And the other aspect is, of course, that I would like to establish and secure future of the lab. Of course, I am personally interested in this neuromorphic stuff, which I would like to find founds for. And this is, of course, in progress. And we have nice connection. We have nice connections. We have a research planned. And if it's of any interest for any of attendees, I would welcome any insights and cooperation. But of course, we want to also in the context of computational medicine, we have two topics of mostly like that can be clinically applied. So stroke related and tumor related, like glioma related. We have also like two projects with the possibility of commercialization, and I won't tell you about it right now, like publicly, because yeah, we want to commercialize them. But it is in relation to this manifesto that we want to connect our research with actual human beings in the hospitals or in the rehabilitation, like as fast as possible. This is like my goal also.
Well, maybe it would be reasonable to display once again the slide you have displayed, the slide with, let's say, different area of interest of team, of the members of your team. And well, my question, not the question, my point for discussion is how you think that all this will somehow what we see on this slide will go into the direction which well, this idea you have presented in this, let's say, in the second part of the slide. Do you think that it will be necessary to somehow to change some research ideas, or do you have idea to let's say to modify something which is going on now, or to let's say to find collaborators for new project?
Yeah, so of course there is nothing like inherently wrong with research being done on this, I call it disembodied data, like the anonymized recorded historical data in which you can find interesting patterns, you can create models and so on. So this is not like something wrong with the research, but it's medically insufficient, I would say. So I think I would like this to move towards like clinical or preclinical applications wherever this is feasible. So this research is that you can see on the slide is ongoing. This is not going to change in any way, but I will try to actively seek areas where it can be applied in the like real life scenarios, medicine. So, but it's not an easy thing to do, and of course I would welcome all the cooperations with clinicians, with practitioners. This is something we can discuss. Yeah, this was my call to cooperation. If you're at least slightly interested in this area and you can see like application in your context, please let us know and we will discuss what can we do.
Well, I have also a question about because all this which is related with this type of research is related somehow with understanding how brain function. Yes, so it is partially research which are performed by Jean. And mm, how do you put this type of research in having in mind, for example, that in Europe we had this very well with a lot of money funded project Brian, and what type of let's say a specific area or research you find which were not let's say touched by these people in this Brian large project?
So, like all these projects are related to, because this is neuroscience, are related to how the brain works, or sometimes how it doesn't work. I believe that this is not the case that we look for the areas that weren't touched at all by other research teams and like big European agencies. But I believe that we have new things to tell about this particular cases, and probably in each and every case we have some novelty. Of course, it would require for me to go through all the papers mentioned here, which I can't do given time. But for example, like from my personal research, this is neuromorphic computing. We have the application, for example, of neuromodularity, neuromodulators in optimization of spiking neural nets, which is something very fresh, and there is not a lot of research around that. So there are nice ideas. Well, even today I discussed with John like nice new ideas around brain connectivity in gliomas, but I promise to not disclose it yet because the publication is in preparation. So yeah, soon.
Well, okay, and there are also, I think, two important, let's say, issues which probably would be to discuss. First of all, what type of measures are you going to apply in order to, let's say, to somehow to make a kind of integration of research in your team, in the sense that different topics sometimes in research teams sometimes lead to something like let's say separation of researchers, and how it is interesting how to let's say overcome such a danger. And on this is one point which is worth to discuss, and the other one is related with collaboration with other scientists. For example, with I think that what in Sano is very close to your research is all these ideas, collaboration with Asia scientists, which are brought by Wiesław, and also with other research teams. So, do you have any specific ideas about these two, let's say, two important, in my opinion, issues in leading such a team?
Yes. So when it comes to cooperation and the topics, if you take all the legacy projects that were, initiated during last few years, and if you focus on the core research that is the most important for every PhD student and for our postdoc, you will find that they converge around the areas of the topics of stroke and glioma, and this is spontaneous core of research right now that will be followed because it's ongoing. So it happens, autonomously when you just focus efforts on actual important projects that are in workshop, that are being pursued actually. So this is like trimming, a tree. If you cut off the extra branches, you will see that there is trunk and there is core, there is a root of research behind it, and I'm seeing it happening right now while we discuss our research with members of the lab. It's happening spontaneously, almost without necessity of reviewing the research or pivoting. And when it comes to cooperations, then of course we have different proposals in making. Also there is a question. I will just finish. Of course, my goal is that we will, with most of the labs. So currently, we of course have ideas and things that we will follow up with functional and structural genomics, so with Tomek's lab, with Przemek's lab. We have nice ideas for cooperation, but right now it's also the problem of resources. PhD students focus on their PhD and pursue other research. We will look for other resources. Interns, master students are resource to use, and it will be used in the near future.
Thank you. Well, could you please have a look at the question and answers on? Yes, because there is a question from Stefan.
I would like to start my PhD this year.
Yes.
Okay,
I think that it is just addressed to you, and probably it would be good to have a, let's say, direct contact with Stefan. I don't know who is Stefan.
So I won't answer in details, but Stefan, please write me an email, and if you are in Kraków, come visit and we will discuss the possibilities. But of course, we can work together.
So I hope that Stefan will contact you. And now we have Wiesław who is ready to take part in discussion. Wiesław, please go on.
Thank you, Marian. We have also snow in Warsaw.
Oh.
Is it good or bad for Warsaw?
Yeah, looks good if you are staying at home. Thank you for your presentation. Thank you for your new thoughts and new direction. Of course, it's not so easy starting a new group, new direction within a very short time, to have all this work done and new directions proposed. But the question is, how much influence in your new directions was from your team members, and what is the level of their enthusiasm regarding new directions?
Okay, so, well, this is the question to be asked to the team. Are you enthusiastic, guys? Yeah, so jokes aside, of course, it is all, we are meeting a lot, we are discussing a lot, and this is all within their research. I'm not imposing anything inherently new. I'm just trying to, frame it in the way that it will be consistent. It won't be scattered research. It will have this. I put this arrow on the screen because I would like us to converge in a very particular direction. So I think they don't mind. This is my feeling right now, and of course all the research will be continued. Like I'm not imposing anything against anyone's will, so I guess this is something. I don't know if that answers your question, but
Okay, I have another one. I
yes.
like this arrow pointing to applications.
Oh,
And
yes.
in fact, it's a sort of follow-up to Marian's question, because of course Marian asked you within 1 year. I agree, within 1 year you have more legit, but what's your vision for 3 years? What sort of new technology you believe you will be trying to develop, and what sort of new clinical solutions you'll be trying to get? Of course, it's an issue of manpower, funding, and so on. But I am just asking about your vision and your personal goals.
Okay, so in terms of technology, so I've started like new path to like I'm trying to create shortcut to commercialization with 2 projects related to straw, and I will try to, not to how to say,
Spoil it.
yeah, not to spoil it. This is one thing, but also I will try not to, dig into presentations and building abstract showcases. Our goal with Rosemary and with Jamal right now with this project is to push it towards patents and market as fast as possible, like taking all shortcuts available, and I will see what will happen with that. So this is one way of doing it, and the other way is, of course, we will try to participate with some of ideas in clinical and preclinical trials. And there is one idea by Joan and his connection that will help us do it. But again, this is something that I don't want to spoil. We can, of course, discuss it in person. I will be very happy to tell you about it, but it's not like for public disclosure yet. Sorry for being, such
Yes,
serious.
keeping in secret.
It's good to have confidential information. It's very useful.
Very useful.
When it comes to application, it is important to not to spoil it too fast. When it comes to research, this is like all open book and of course open science.
Okay, I also want to follow up with Marian's question about this Asian connection, because it looks that there might be some substantial funding, but also very high requirements. And personally, I see two potential niches. One niche is to use incubation. You already are familiar because we had some email exchange and I sent a paper. But the second niche is what we already started to do with the Synapse, namely they start acquiring vascular data of non-private, non-human privates. So you got marmoset and so on. The question is how to do segmentation, and even more important, how to do labeling. I have thrown some thoughts and so on, but of course, having a model at the level of 1 micron resolution will be very challenging. But recently, what they told me that they plan to be able to process 1 marmoset brain a day. So meaning they might be coming to hundreds of brains. And of course, to do that manual, it's not possible. And they are thinking how we can use AI to do this job. Do you think you might have some ideas how to do that and how Sano could contribute?
Well, we can definitely contribute in terms of uh, segmentation and data analysis, because we have these abilities, and we can use probably our infrastructure available to do that. But in my very honest opinion, at this point, we would require like additional, maybe not full team, but people to help with that, because we don't have like personal resources to do that at this moment. So if it can be part of this proposal that we will like invite people to work with us at this lab, I think we will find some expertise to do that, but we would need like additional resources, because at this point
I think here there are two issues. One issue is, do we know how to do that? And we need resources to execute, and we don't know how to do that, and we need resources to find a solution for us. So I am asking, do you think that you in your team at Sano, there might be enough knowledge to know how to solve it, providing that resources are given, or rather not?
Yeah, so Jamal is nodding his head, so I think this is the answer is positive, but
I think if we have discussed it before about this project, right? Is it the same one?
Yeah, it's the same project, but what we discussed, what we submitted to NCBR was just one model without using AI. Now they're saying we are able to speed up the whole processing. We are able to process maybe with hundreds of brains, and we need AI. So it's a completely different approach.
Okay, then I mean, yeah. Theoretically, that sounds doable, but yeah, it will take some time and effort again.
It is. Sorry if I can interrupt, because even if I'm not actively involved in this, I did think of it just for fun. And as far as my understanding goes right now, is that if we want to use AI, we either need a set of labels, so we would need a manually or perhaps a traditionally segmented marmoset brain that we can use as some sort of ground truth. That would be one approach. So if we have one segmented brain, we could use this type of this brain as some sort of proxy to train our AI models. If we don't have that, then we need to go into unsupervised methods, which are slightly more tricky because they are unsupervised. So I do think that we might possess the knowledge within Sano in different teams. So in terms of theoretical understanding of what is needed and in practical understanding of how to implement this theory. So I do think that we have this knowledge. However, implementing this knowledge and whether if it works in the first try or not is something that it's hard to predict. That's my opinion and my thought, which would need probably dedicated resources in the end.
Yeah, I agree that this is like we will probably find knowledge, but we won't find resources at right now. But you know, if the grant proposal passes, then we can build around that. So I think it's feasible entirely.
Yes. For example, Przemek's team, they are super experienced in segmentation models. However, this is a different problem, so it might require a slightly different theoretical approach from the beginning, which is something that I'm.
Okay, yeah, thank you.
Well, okay, so it seems that we have reached the time devoted to this event for today. So many thanks for participation, many thanks for discussion. I hope that it will be something which will help to reach objective of this team during this year. Many thanks, and I would like to invite you all to the next Sano seminar, which will be in a week from now, as usual at 2 o'clock, and it will be devoted to implants and artificial intelligence. Well, I will distribute an announcement on Wednesday, so you will get more information very soon. Many thanks, and see you in a week.
Thank you very much. Goodbye.
Bye.